This is the first episode of a 5-part series where we'll build different types of intelligence software from scratch. I call the series Using AI to Understand AI, mainly because we will rely on codecs from OpenAI to build things quickly and efficiently. We'll begin with traditional machine learning, then build a tiny language model, and after that apply the approach most software solutions use currently, which is to integrate an existing model into a real application. In this case, we will use GPT-4o Mini. In the fourth video, we will build a rule-based workflow engine and finally bring everything together in the last video of the series. My goal isn't to simply teach you how to build these applications. It's to help you build a mental model of modern AI, what these systems are designed to do, where they work well, where they don't, and ultimately help you make better judgments about many of the claims surrounding AI today. We will start by building the application itself. I will ask codecs to create a simple Express backend and React frontend, but you should note that we are already planning ahead. The project also contains an empty machine learning folder. That's because today's application isn't complete until it can actually learn from historical data. Before a machine learning model can learn anything, it needs examples. In this case, our examples are simply historical time entries for different legal tasks. These aren't rules or formulas, they are observations from previous work, and they'll become the experience our model learns from. Codex has now generated the application skeleton. I'll fast forward through the generation itself because the interesting part isn't watching code appear. It's understanding the architecture that has been created and how we'll gradually extend it throughout this video. Let's now install the dependencies and start both applications. When I say both, I mean the backend, which is run on Express, and the frontend, which is a React component. At this stage, we have a working interface, but it doesn't yet contain any intelligence. That's intentional. We'll first build the application, then teach it how to learn. The application already lets us record historical work, but notice what happens when we ask for an estimate. The application tells us that no prediction model exists yet. This is an important distinction. Software alone isn't machine learning, of course. We still need to build and train a model before predictions become possible. Now that we have the application, it's time to build the machine learning model itself. Rather than mixing everything together, we'll keep the learning logic separate from the user interface. This separation makes each part easier to understand and mirrors how many real-world applications are organized. Codex has now generated the machine learning project. In a moment, we'll train the model using the historical examples we looked at earlier. Up until now, the application has simply been storing data. The next step is where learning actually begins. Before we can train the model, we need to prepare the Python environment. Machine learning often relies on libraries that are separate from the rest of the application. So keeping this part isolated makes the project easier to manage and reproduce. This file is responsible for training the model. It loads our historical data, creates the linear regression model, trains it using those examples, and finally saves the learned parameters to disk. Once the model has been trained, we don't need to repeat that process every time. Instead, we simply load the saved model whenever we want to generate a prediction. This is the key moment in today's video. The training script loads the historical examples, learns the statistical relationship between the task and the recorded time, and saves the resulting model. From this point onward, the application can use what it has learned instead of relying on manually written rules. Let's test the model before connecting it to the application. I'll ask it to estimate the time required for drafting a contract. Notice that the prediction comes directly from the trained model we just created. We aren't hard-coding these numbers anywhere. This file contains the trained model itself. These numbers represent the parameters the model learned during training. They don't mean much to us directly, but together they capture the statistical relationship the model discovered from our historical data. This is ultimately where today's predictions come from. Our machine learning model now works on its own. The final step is to connect it to the application we built earlier so that users can benefit from those predictions without ever interacting with Python directly. While Codex generates the integration, notice what we've built so far. We have a user interface, a machine learning model, and historical data. The final piece is simply allowing those components to communicate with one another. The integration is complete. Our application can now call the trained model whenever a prediction is requested. This separation between the application and the machine learning model makes the overall design both simpler and easier to extend. Everything now comes together. The user simply selects a task and requests an estimate. Behind the scenes, the application loads the trained model, generates a prediction, and presents the result through the interface. This is a simple example, but it demonstrates one of the core ideas behind traditional machine learning: learning from historical examples in order to make useful predictions about new situations. Today, we've built a complete machine learning application from scratch. More importantly, we've seen that this kind of AI isn't mysterious. It learns statistical relationships from historical examples and uses them to make predictions. That's very different from understanding language or reasoning about the world. In the next episode, we'll move from numbers to language by building a tiny language model from scratch. As we continue through this series, we'll keep comparing these different approaches so that by the end, you'll have a much clearer understanding of what modern AI actually is, what it isn't, and why those distinctions matter when evaluating the many claims we hear about AI today. Thank you for watching.